Hi everyone. Uh, my name is Madam Rosmaya. In this video, we are going to discuss on Newton's laws of motion. Okay, so what is Newton's laws of motion? Newton's laws of motion are three physical laws that together laid the foundation for classical mechanics. They describe the relationship between a body and the forces acting upon it and its motion in response to those forces. So these three laws have been expressed in several ways over nearly 3 centuries and can be summarized as follows. For Newton's first law, objects keep on doing what they are doing. In the Newton's second law, more mass means more force needed to accelerate. And in Newton's third law, object keeps on doing what they are doing. So the first law defines the force qualitatively, and the second law offers a quantitative measures of the force. The third asserts that a single isolated force doesn't exist. So we are going to discuss these three Newton's law in detail. So Newton's first law states that an object at rest remains at rest and an object in motion continues in motion with constant velocity, that is, constant speed in a straight line, unless it experiences a net external force. So example given in this animation. So without being properly secured, the ladder continues moving forward even though the truck stops. Another example is the second animation given here. Without a seat belt, the man continues moving forward even though the car stops. So this explains why objects keep on doing what they are doing. So the tendency to resist change in motion is called inertia. Okay, next we discuss the Newton's second law. Okay, Newton's second law states that the rate of change of momentum of a body is directly proportional to the resultant force acting on it and is in the same direction as the resultant force. So from the statement here, we can write in mathematical form where F equals to dp by dt. So P is a momentum equals to mass time velocity. So substitute mv into the equation, we have dmv per dt. So using derivation rule, we get a v dm by dt plus m dv by dt. So there are four possible explanation from this statement. So we will discuss in four different cases. So the first case, where the mass constant and the velocity changes over time. So from the equation here, so mass constants means dm by dt is equals to 0. So the equations become F equals to m dv by dt. So dv by dt is equals to A, acceleration. So example here, acceleration will increase when a larger force is exerted. So in the second case, acceleration constant and force changes. So from F equals to ma here, if the acceleration constant, so the changes will be in the F and m. So in this example, if the mass increase, a greater force is needed for the same acceleration. Okay, next, the third case is where the force constant and mass changes. So force here constant, mass and acceleration change. So how they change? Acceleration will decrease when a larger mass in the cart is pushed with a constant force. And the fourth case, when the velocity constant and mass changes over time. So this means the velocity constants, this term here, dv by dt is equals to 0 because there is no changes in velocity. So the term dv by dt equals to 0. So the equation becomes f equals to v dm by dt. For example, in the rocket, launch of the rocket here. So the greater the mass of the rocket fuel burned, the faster the gas produced can escape the engine. So this represent the mass changes with time. So the greater the upward thrust of the rocket. So the represent the F here. So the larger the rate of change for mass, so the larger the force. In this example, the upward thrust of the rocket will be greater. Okay, another example is in the conveyor belt here. So the sand from a stationary hopper falls on a moving conveyor belt. The conveyor belt is supported by a frictionless rollers and moves at a constant speed. So represent the constant speed here, V. So the mass, the sand drop here represent the dm by dt, the rate of change of mass. Okay, and it moves at a constant speed under the action of a constant horizontal external force supplied by the motor that drives the belt. Okay, next we discuss the third law. Newton's third law states that if two objects interact, the force exerted on object 1 by object 2 is equal in magnitude but opposite in direction to the force exerted on object 2 by object 1. In other words, forces always come in pair when two objects interact. So the forces are equal but opposite in direction. So example in the animation given here, when you jump off a small rowing boat into water, you will push yourself forward towards the water. So the same force you use to push forward will make the boat move backward. So in the second animation example given here, when you dive off a diving board, you push on the springboard. So the board springs back and forces you into the air. So the board springs back and forces you into the air. Okay, so that's all for the introduction to Newton's law of motion. So we will discuss on the calculation part in the next video. So that's all for this video. Thank you for watching.